Welcome to qnawire.
Hello students, so the question is to find the amount of the Br liquid, the bromine liquid which is formed from the reaction. So here the volume of the solution is given 50 ml. So here we'll divide this by 1000 to convert it into liters and it will be 0.050 liter. And here we have been given the concentration of NaBr which is 0.1% weight per volume. So it means that 0.1 gram of NaBr is present in 100 ml of solution. So this is the balanced equation of the reaction. So here we need to calculate the bromine amount. So we have been given the amount of NaBr in 100 ml of solution which is 0.1 gram, but the volume of solution is 50 ml. So here as we can see that 0.1 gram of NaBr is present in 100 ml of solution. So the 50 ml of solution will contain the amount of NaBr which is equal to, so it will be the half of the 0.1 gram of NaBr which is equal to 0.05 gram of NaBr. So as we can see that now we will be calculating the number of moles. So let's calculate the number of moles of NaBr present in the solution. Since we will be using this formula where the number of moles which is denoted by N is equal to the weight upon the molar mass. So here the molar mass of the NaBr is equal to, so here the sodium molar mass is 23 gram per mole plus the bromium mass which is 80 gram per mole. So the total is 103 gram per mole. So this is the molar mass of the sodium bromide and we know the weight which is 0.05 grams. So let's put the value. So here N is equal to 0.05 gram divided by the molar mass which is 103 gram per mole. So here by calculating it will get, so the number of moles of NaBr is equal to 4.85 into 10 raised to the power minus 4 moles. So this is the number of moles of NaBr. So as we can see that from this equation that 2 moles which is the stoichiometry of NaBr. So here the 2 moles of NaBr is producing 1 mole of Br2 bromine gas. So we now the theoretical yield, the actual moles is 4.85 into 10 raised to the power minus 4 moles. So here it will be, so we'll simply cross multiply it. So it will be 1 upon 2 multiplied by 4.85 into 10 raised to the power minus 4 moles. So let's calculate it. So it is equal to 2.42 into 10 raised to the power minus 4 moles of bromine gas is been produced. So now let's use this formula where the number of moles is equal to the weight upon the molar mass. So from this equation we can calculate the amount of bromine by putting the value of number of moles and the molar mass of bromine. So here the molar mass of the bromine is equal to 2 into 80 gram per mole. Since here the bromine atom is 2 and the atomic mass of bromine is 80 gram per mole. So it is equal to 160 gram per mole. So from here let's put the value to calculate the amount of the bromine gas. It is equal to, so the number of moles as we have calculated is 2.42 into 10 raised to the power minus 4 moles multiplied by the molar mass. So it is equal to, so here we'll multiply it and it is 160 gram per mole. So let's calculate it and it is equal to is 3.872 into 10 raised to the power minus 2 grams. So this is the amount of chromium. I hope you find this video helpful. Thank you.